Dear distinguished guests, esteemed faculty members and fellow students, a very good morning to all of you. On behalf of the Environmental Science and Engineering Department and the Environmental Science and Engineering Association, it is with immense pleasure and excitement that I extend a warm welcome to everyone who has gathered here today. We are here to celebrate World Environment Day, a momentous occasion that reminds us of the significance of our planet and our responsibility towards it. World Environment Day serves as a global platform to raise awareness, inspire action, and drive positive change towards environment and sustainability. Today, as we stand here united, we reaffirm our commitment to safeguarding our planet for future generations. In this spirit, it is our honor to receive Professor Ajit Annachhatre, Emeritus Professor at the Asian Institute of Technology, Bangkok, Thailand, and visiting faculty at Indian Institute of Technology, Mandi, as our guest speaker. Professor Annachhatre holds a distinguished academic background. It makes us proud that he is an alumni of IIT Bombay, having completed his PhD in Environmental Engineering from the Environmental Science and Engineering Department, formerly known as the Center for Environmental Science and Engineering. In his 28 years of illustrious academic career, he has over 150 publications and has supervised 18 doctoral and over 125 master's students. He has made significant contributions to the field through his insightful work on sustainable water management, waste treatment technologies, and the impact of climate change on ecosystems. Today, Professor Annachhatre will share his expertise on the impact of climate change and the various methods available to combat this global challenge. So, let us embrace this gathering as an opportunity to learn, exchange ideas, and ignite the sparks of change within ourselves. Now, I would like to request Head of the Department, Professor Shubhankar Karmakar, to extend his welcome to all the guests and invite Professor Annachhatre to the dais. Thank you.
Thank you, Vasudev. I will hold it in hand. That is good. It's fine. Yeah, so very good morning, everyone. It is indeed my immense pleasure to welcome you all to EACD seminar talk by Dr. Annachhatre. So, on behalf of our department, I convey my sincere gratitude to Dr. Annachhatre and Mrs. Annachhatre for visiting our department. And with today's research talk, we would like to celebrate World Environment Day 2023. And remember, this is the 50th year of celebrating World Environment Day. And it was led by United Nations Environment Program on 5th of June 1973, and this year's theme is a solution to plastic pollution. So, under the campaign Beat Plastic Pollution. So, I would like to thank Professor Dikshit for all his efforts to arrange today's event. I also thank EACD Student Council, EACA, and all students for their efforts and mainly the assistance. So, then without any further delay, I would like to formally invite Professor Annachhatre to deliver his talk. So, thank you so much.
Hello, is it on?
Yeah, like this. You will have to
Hello. can keep it here also if you want.
Yes, you can remove this knot.
Okay, all right. Okay. Good morning, everybody. I'm very glad to be here today and particularly thankful to Professor Dixit and Professor Karmakar for inviting me here today. Well, I have a sort of a nostalgic feeling today, particularly because I'm happy because this is my alma mater. I studied here, so it's always nice to, it's a homecoming, so that is one. But I'm a little bit sad as well because some of my teachers are no more. Professor Khanna and Professor R.S. Patil, I think some of them are no more. So I remember them. So that makes me a little bit sad. But nevertheless, I'm very happy to be here. I particularly welcome Professor Sane, who has been a very senior professor from IIT. He retired 18 years back from aeronautical engineering. So welcome to Auntie as well as my Professor Sane. Okay, so I will start today's presentation. I will have as the title of my talk suggests, I will be talking on impacts and methods to combat climate change. Am I coming in between you? Are you okay? I will go through in this sequence. First, initially, we'll make a comparison of Earth with the adjacent planets, namely Venus and Mars, and what we can learn from them. Second, I will cover some of the science behind climate change. Okay. Then characteristics, typical how the Earth environmental systems work. What are the background principles behind it? Not all of them, but pertinent for today's talk. And then we will go through things like impacts of climate change on water cycle, forest fires and polar ice caps. And we will finally have a look at how we can combat climate change through international treaties, what are the efforts ongoing, shift to renewable energy sources, which is an important part. Human civilization will have to make this adjustment sometimes or the other in the next 200 years or so. And finally, what an ordinary citizen can do to combat the climate change. Okay, what in our lifestyle, what changes can we make to combat the climate change. So we'll start today. So this is our solar system, as we know. Navaratna, new 9 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Pluto is degraded; it's no more. It's not considered to be a planet now. But if we take that, then we have 9 of them, and here is Earth, we have Venus and Mars. So we are going to compare these 3. Okay, let's see what is the comparison. Okay, to start with, nearly 150 kilometers separate the Sun and the Earth, yet solar radiation drives Earth's weather. Okay. Here is the comparison. Okay. And this comparison can bring a wrong conclusion. Okay. The conclusion, let us see what. Okay. The distance is the first row, Venus is 108 millions of kilometers, Earth is 148 millions of kilometers, and Mars 227 millions of kilometers. So, we know this. Solar constant, this is the energy received on the surface of each planet. Okay. Venus is about 2636, Earth is 1361 watts per meter square, and Mars is 586 watts per meter square. Now, this can lead to a conclusion that because Venus is the nearest of the planets, the temperatures would be highest here and lower than this here and lower than this here, which is in fact the case. The temperature on Venus is 450 degrees centigrade, on Earth, this is average temperature I am saying, 13 degrees centigrade, on Mars it is minus 53 degrees centigrade. But what could be the reason? The reason, we tend to think that it is because of the distance, but it is only partial, it is not fully correct. Okay. The reason for that is here. Venus has atmosphere that has got 96% carbon dioxide. Okay. Earth has got 0.04% carbon dioxide, and Mars has got 96% carbon dioxide. Then you would say, well, then why not here? The problem is about the same. Well, the problem is again here. You can see Venus has got pressure 92 times of Earth, 92 times atmospheric pressure. Okay. And hence it is heavily filled with carbon dioxide, lot of carbon dioxide is there. And what is carbon dioxide? Carbon dioxide we know is a greenhouse gas. So, whatever energy is incident upon Venus, everything is trapped, everything is trapped because of carbon dioxide. Yeah? And nothing goes out. Whatever goes out is because of radiation. Okay. So, Earth is one atmosphere and Mars is very low. This is the reason why, even though 96% of Martian atmosphere is 0.6% of that of Earth. So, this is the reason why the temperature here is so low. Okay. So, we can what can we learn here? We can learn here, this is a runaway greenhouse gas effect. Okay. It has the greenhouse gas effect, the climate change effect on Venus is so much because there is so much of carbon dioxide there, it just out of control. Okay. On Earth we have just about good carbon dioxide, amount of carbon dioxide. On Mars it is too less, okay, because the atmosphere is too thin. So, what we can learn from this? One is we should not have more carbon dioxide. Okay, that is for sure. That is which is a greenhouse gas. Okay, so this is a runaway greenhouse gas effect. This is just about good carbon greenhouse gas effect, and this is too low greenhouse gas effect. So, this is what we can learn from it. Okay. The Earth has something special. Okay. Now, always these three planets, Venus followed by Earth followed by Mars, are good candidates. They are considered to be good candidates for life. Okay. And often scientists, when they look at the outside galaxies, they look something similar always. What are the planets similarly placed to as compared to Venus, Earth and Mars. So, life on Earth is supported because of Earth's size Earth's density, well, in maybe in the childhood some of you have studied Goldilocks, remember Goldilocks, okay, just not too big, not too small, okay. So Earth size is not too big, not too small, just good enough, okay. Earth's density is the same, not too big, not too small. Earth's average distance from Sun, not too large, not too small, is the same thing. Earth's gravity and Earth's surface temperature. Now this is an interesting part, okay, which I am going to enlarge a little bit. The average temperature on Earth's surface is 16 degrees centigrade. Well, this is because we have carbon dioxide in the Earth's surface, okay. If that carbon dioxide wouldn't have been there, okay, it's a small amount, okay, but if that wouldn't have been there, or if that greenhouse gas effect wouldn't have been there, the temperature on Earth would have, average temperature would have been minus 23 degrees centigrade, and no life would have existed, okay. So to call that greenhouse gas effect is bad is not correct, okay. So it is good, and we are here because of that, okay. And if that were not there, everything would have been frozen here on Earth and no life would have existed. So this is what it is. The average Earth surface temperature as controlled by solar constant, that is solar, we have seen that, and the greenhouse gas effect of the atmosphere allows water to exist naturally in all its three phases, namely solid, liquid and vapor. And this is what is responsible for the life on planet Earth. But we as a human beings are altering many things, okay, and we will have a look at them as we go. So this is the this we know, okay. This is the composition of pure dry air near Earth's surface. Nitrogen is predominant, 78%, oxygen is 21%, argon 1%, and other gases, that makes it total of 100. Okay. Now these are not greenhouse gases, neither of this. These are not greenhouse gases. Well, there is something special about Earth, okay, Earth's atmosphere. Okay. Well, Earth's atmosphere is like a jacket. Earth is wearing this jacket. Okay. What does it do by wearing jacket? Well, jacket has two properties, any jacket. One is the thickness and the material. Okay. The thickness will, both of them are necessary for controlling the temperature. Okay. Now during winter time you wear a woolen jacket. Woolen jacket you wear because it has got very less K value. K, that is the heat conductance, okay, is very low. So you protect heat, right? But during summer time you cannot wear woolen clothes. It's not possible, because otherwise it's going to keep all the heat inside, which will make you impossible to live. So this is what it is. The Earth's atmosphere is like jacket which is protecting the Earth. Okay, it is protecting the Earth. But then what is happening? I told you two properties. One is the thickness. Earth's atmosphere is about 110 kilometers thick, not very big. 110 kilometers is less than the distance from Bombay to Pune. Is not much, right? Is less than that distance. So it's about 110 kilometers. So a major one. Okay. So but it has stayed like that for 4.8 billions of years. Now you know any solar system has a typical age of 10 billion years. Okay. Typically 10 billion years. What is billion? 10 to the power of 9. Okay. So 10 billion years, that's a long time. So we have lived about 4.8 billion years. Okay. We still have 5.2 billion years to live on this planet. Okay. That is a lot of time to live. Okay. Now, in the final stage of solar evolution, sun will be a red giant. It will be a red giant. Okay. So, that phase may last for over 1.5 billion years. If you remove that, because during that time nothing will exist on earth, everything will evaporate. Okay. So, so you still have about 3.5 billions of years to live on this planet. Yeah. Are we going to sustain that? Are we going to sustain that? That is the problem. Okay. What are we going to do? What are we doing? In this jacket of atmosphere, we are changing, we are not changing the thickness is constant, okay, 110 kilometers, but we are changing the composition, that is we are changing K value, okay, we are changing the composition. How are we changing the composition? Let us have a look. Well, this is the atmosphere, not to the scale. Okay. We have the lowest one, troposphere, followed by stratosphere. Troposphere is about 20 kilometers, stratosphere is next 50, stratosphere contains the ozone layer. So, ozone layer. Okay. Now, this is another problem that humanity has introduced, you know, the ozone hole, yeah, which has been there because of hydrochlorofluorocarbons, right. So, those are responsible, but humanity somehow has solved this problem, okay, because of the Montreal Protocol in 1987, Montreal Protocol, where all chlorine containing compounds were banned, which were used in refrigeration, okay. And then now the ozone layer has come back. Okay. Now, it is ozone layer, you can see, has improved so much, now it is almost back to its normal shape. So, this is your stratosphere, mesosphere, thermosphere and exosphere. Well, here it is up to this point, a thermosphere, 110 kilometers. Okay. This is the weather. Outside is really not much of a gases they are there. Okay. So, 110 kilometers up to here is the. By the way, climate and weather, the difference most of you must be knowing. What is the difference between climate and weather? Weather is daily variation of the climate, okay, but climate is the average of weather for 30 years, that is climate. Okay. So, that is the difference, keep that in mind. Okay. Well, we receive, let us quickly have a look what is this greenhouse gas effect. Okay. What do we mean by, because we listen this word very often, you know, what is it? Sun emits its rays. When it is received by earth, some part of it is reflected back into the space, some part. Okay. Some part of it goes through the atmosphere, right. Now, the part of sun rays that goes through the atmosphere is incident upon earth's surface, it could be soil or water, ocean, which is absorbed by the earth. Okay. And now, that radiation is re-emitted. Okay. This is the re-emitted one. Okay. Now, that re-emitted energy is in the form of heat, which has got infrared frequency and which is a weak radiation. It cannot, not all of it goes out. Okay. So, some of the energy is trapped by the earth's atmosphere because of the infrared radiations, and some of this energy goes out. Okay. And that is why you see outside in the space you see earth, which is because of this radiation going out. Okay. So, now the problem is here. Okay. here. What happens to this energy? This energy remains in the atmosphere. Okay. This remains in the atmosphere, just it goes back, again is re-emitted, again is comes back. You know, you have the an endless loop